Welcome to the FMSP online revision. This session is for AQA M1. The topic is projectiles and we're looking at question 7 from January 2010. So the ball is projected horizontally with speed v meters per second at a height of 5 meters above the horizontal ground. When the ball has travelled a horizontal distance of 15 meters, it hits the ground. So we've got the diagram there which we can make use of. Firstly, we're asked to show that the time it takes for the ball to travel to the point where it hits the ground is 1.01 seconds, correct to 3 significant figures. Then we're asked to find v, this horizontal velocity. In part C, we're asked to find the speed of the ball when it hits the ground. And in part D, find the angle between the velocity of the ball and the horizontal when it hits the ground, giving your answer to the nearest degree. And in part E, we're asked to state 2 assumptions that you've made about the ball when it is moving. So let's have a look then at the beginning. So we have horizontal and vertical motion. And in part A, we're really only interested in the vertical motion. So let's think about what's happening vertically. So vertical motion, so it's horizontally projected, so that means there is no vertical component to the velocity. It travels a distance of 5 meters down, and I'm going to take, since it is only travelling downwards, I'm going to take downwards to be positive. And of course, the acceleration is going to be due to gravity, because we're modelling it as a particle. And what we're being asked to do is to find t, find the time taken. So we're going to use s equals ut plus a half at squared, because that's the equation of motion which connects the information that we have. U is equal to 0, so we have 5 is equal to a half a, so that's 4.9 times t squared, and so t squared turns out to be 5 over 4.9, and if you take the square root you get t equal to 1.0102, which of course that means it's 1.01 seconds to 3 significant figures. So that is the first part, that's part A. Then in part B, we're asked to find v, so we're now considering what this horizontal motion and what this horizontal velocity might be. So u is equal to v, the initial velocity. It travels a distance of 15 meters, and we've now worked out it takes a time of 1.0102. Now I'm not going to use the rounded figure here, so try always just to use the value that's been stored in your calculator. And so we're using s equals ut. We don't have any acceleration. Acceleration, remember, horizontally is 0, so you don't have any. A half at squared is just going to be 0. So we end up with 15s divided by t, which is 1.0102, and that is going to be the velocity. And if you work that out, that turns out to be 14.84, and possibly a bit more. I think it's a 9 actually here, but it will be, if we're giving the answer to 3 significant figures, that will be 14.8 meters per second. So we've now found v. So let's see what we need to do now. We're in part C, we're asked to find the speed of the ball when it hits the ground. So if we just bear in mind now, we have got the horizontal velocity, we know, because we've just worked that out, because remember that that doesn't change at any stage. So that was the 14.849, and again I'm giving it in its accurate form. Remember that that remains unchanged because of course there is no horizontal force, so there is no horizontal acceleration, so that velocity remains constant. What we need to know now is we need to know the vertical speed. So that's all the vertical velocity. So if you remember, vertically we knew that it started off with an initial velocity of 0, that acceleration was 9.8, and we also know that the time is 1.0102. And again we were using downwards to be positive, which is why I've taken A to be 9.8 plus 9.8. So if we use V equals U plus AT, then we can find the vertical velocity. So that's going to be U is 0, so it's 9.8 times 1.0102, which turns out to be 9.8 and a whole load of nines. Now we're going to use that accurate value, but basically we've got the vertical velocity. Now we know that that's what that is, and horizontal velocity was 14.849. So what we're having to do now is we're having to think about the speed. Oops. So we need, basically we're just going to be using Pythagoras theorem. So let's just do that and just remind ourselves. So the horizontal velocity (14.849), vertical velocity, and again as I say, taking the accurate answers, 9.899 and so on. So the speed is going to be, by Pythagoras theorem, the speed is going to be the square root of 14.849 squared plus 9.899 squared. That would be sufficient accuracy, really, if you haven't stored it in your calculator. That works out to be 17.84, which is 17.8 to 3 significant figures. So the speed of the ball, that's part C. If we just go back to the diagram, it then said to find the angle that between the velocity of the ball and the horizontal. So basically we're wanting to find that angle, if we call it alpha. So this was 14.849 and this was 9.899. So the tan of alpha is going to be the vertical velocity over the horizontal. So in part D, if we write that there, then tan of alpha will be equal to 9.899 over 14.849. And again, just checking on your calculator and giving your answer to the nearest degree, that turns out to be 34 degrees. It was 33.69, but as I say, the question did specifically say to the nearest degree. And then part E, the last part, state 2 assumptions that you've made while the ball is moving. And the first of all, we have treated it as a particle. And in projectile motion we always treat it as a particle, and we also work on the basis that the only force acting on it is its weight, so that there is no air resistance. And those are the modelling assumptions that we tend to make when we're doing questions on projectiles. So if we just have a look at how the marks were awarded for the question, just going back to the beginning. So in part A you had 3 marks. So the 3 marks, you got a method mark for using your s equals ut plus a half at squared with u equal to 0, and an accuracy mark if you got that all correct, and then you got an accuracy mark for your time. To find v, you got a method mark for using speed equals distance, distance equals speed times time, and an accuracy mark for getting that velocity. And then going on to the next bit, part C, then you needed to find the vertical velocity. So you got a method mark for using v equals u plus at, and an accuracy mark for finding the vertical velocity. And then you got a method mark here for finding the speed. Now that method mark was dependent on you correctly getting the velocity, the vertical velocity. And then there was an accuracy mark for getting 17.8. And the last little bit, a method mark for your using tan, or correct trig function. That was a method mark, and then you got an accuracy mark for getting anything that rounded to 34 degrees, and if you did actually do your rounding, you also got another accuracy mark. So if you did need to make sure you rounded it to get your second mark there. And then the last bit, there were 2 marks independent of methods, so a mark for each of those assumptions that you would make. So 14 marks in total for the question. So don't forget that if you want to access further revision videos, then just go to the FMSP website and follow the link to online revision.